Have you ever just stopped for a second, looked around you, and really wondered, what is all this stuff made of? It sounds like a simple question, right? But the answer is one of the most important ideas in all of science.
Think about it. The screen you're looking at right now, the air you're breathing, even your own body, it's all made of something scientists have a simple name for: matter.
So, what is matter, exactly? Well, it's pretty straightforward. If it has weight and it takes up some space, boom, it's matter. And today, we're going to break this whole idea down and see how it really shapes our entire world.
All right, so here's our game plan. We'll start with that big question, then we'll get into the difference between mixtures and pure substances. We'll take a tour of the world of mixtures, dive deep into elements and compounds, check out a really cool experiment, and then we'll connect all the dots to see why it matters in the real world.
Okay, so when scientists look at, well, anything, the very first question they ask is this: is it made of just one single thing? Or is it a bunch of different things just hanging out together? This one question puts everything around us into two huge categories.
You know, it's kind of funny how we use words in everyday life versus how science uses them. You might see a carton of pure milk in the supermarket and think, great, nothing weird added. But a chemist looks at that same carton and sees something completely different, because their definition of pure is way, way stricter.
See, for a scientist, a pure substance has only one type of particle in it. So that milk, not pure at all. It's loaded with water particles, fat particles, protein particles. You get the idea. You could physically separate them. A truly pure substance, though, you can't break it down that easily.
And that leads us right to that other big category, mixtures. Honestly, this is what most of the stuff around us is. Think about a glass of lemonade, or maybe a bowl of poha. You've got different things physically mixed together, but each ingredient is still just itself. The lemon juice is still lemon juice, the sugar is still sugar.
But here's the thing, not all mixtures are the same. I mean, think about it. In a salad, you can see the lettuce, the tomatoes, the cucumbers, easy. But when you stir salt into water, where'd the salt go? It seems to just disappear.
And that right there is the big difference. That sprout salad is what we'd call a non-uniform mixture. You can clearly see all the different bits and pieces. But the salt water, that's a uniform mixture. The salt is spread out so perfectly, so evenly, that the whole thing looks like just one substance.
And what's really cool is that mixtures can be made from pretty much any combination of stuff. The air we breathe is a uniform mixture of different gases. A can of soda is gas mixed into a liquid. And alloys, like brass or the stainless steel in your kitchen sink, are actually mixtures of solid metals.
Okay, so we've got a handle on mixtures. Now let's circle back to those pure substances. It turns out, even that category breaks down into two even more fundamental types.
This is as basic as it gets, folks. Elements are like the universe's ultimate Lego bricks. You can take an atom of gold, or carbon, or oxygen, and you just can't break it down into anything simpler. That's the end of the line.
And get this, scientists have only found 118 of them. That's it. Everything you see, everything in the entire known universe is built from different combinations of just these 118 basic building blocks. Kind of mind-blowing, isn't it?
So, what happens when you take those Lego bricks and chemically snap them together? You get a compound. And this, my friends, is where the real magic happens. Because when elements combine to form a compound, they create something totally new with brand new properties.
Our source material just nails this point. Let's talk about water, H2O. It's made from hydrogen, which is a super flammable gas, and oxygen, a gas that fire needs to burn. You put them together, and what do you get? A liquid that puts out fires. That is the incredible power of a chemical bond. It's a total transformation.
All right, to really see this in action and make it stick, let's walk through a classic experiment. It perfectly shows the huge difference between just mixing things and actually creating a compound.
So, first up, we make sample A. It's super simple. We just take some gray iron filings and some bright yellow sulfur powder, and we stir them up. That's it. We've made a mixture. If you look closely, you can still see the separate gray bits of iron and yellow bits of sulfur.
Now for sample B, things get interesting. We take that same mixture, but this time we add some heat. That heat provides the energy for a chemical reaction to kick off. The iron and the sulfur atoms actually bond together, and what we're left with is a totally new, solid black substance.
And when you test them side by side, wow, the difference is night and day. With sample A, the mixture, you can still pull the iron filings out with the magnet. They're still just iron. But with sample B, the magnet does nothing. The iron isn't just iron anymore. It's chemically locked into something new. Add some acid, and they produce completely different gases. Sample B is no longer a mix of iron and sulfur. It's a brand new compound called iron sulfide.
So elements, compounds, mixtures. Why should we care, right? Who cares outside of a chemistry lab? Well, it turns out this basic understanding is the foundation of pretty much all of modern technology and innovation.
Seriously, think about it. The medicines that save lives, those are carefully designed compounds. The strong, rust-proof stainless steel in buildings and kitchens, that's a cleverly designed mixture called an alloy. We're even creating incredible new materials like aerogels to help clean up environmental disasters. And this knowledge isn't even new. Ancient artists were masters of creating alloys like bronze for their beautiful sculptures. Understanding how to mix and combine matter is what drives human progress.
So I'll leave you with this one last thought to chew on. Just imagine for a second, what if water wasn't a stable compound? What if it was just a loose mixture of flammable hydrogen gas and fire-loving oxygen gas? Just think about that for a minute, and you'll start to see just how much our very existence depends on the fundamental nature of matter.